Aditi goes to Dunkin' Donuts for donuts and a cup of orange juice. Donuts cost 60 cents each, and a cup of orange juice is $3. Given that Aditi has $12 with her, how many donuts can she get? All right, we're going to use our method for solving word problems. And the first step to that method is understand the problem. To make sure we understand the problem, we're going to ask these 4 questions. To start off, do you know all the words? Well, you might not have heard the name Aditi, but you can tell it's a person. You may or may not have heard of Dunkin' Donuts, but you can tell it's a place where you get donuts. Other than that, we're talking about donuts, orange juice, and money. How much the donuts and orange juice cost. So we know all the words in the problem. Let's move on to the second question. What are you looking for? How many donuts can Aditi get? So let's make a note of that. We're looking for the number of donuts Aditi can get. Okay, we can move on to the third question. What info are you given? Well, in the first sentence, we can see that Aditi is getting donuts and a cup of orange juice, and also that donuts are 60 cents each, and a cup of orange juice is $3. So let's make a note of that. Aditi is getting donuts and a cup of orange juice. And the donuts are 60 cents each, and a cup of orange juice is $3. So it might seem like we're just rewriting the problem, but what we're doing is organizing the different parts of the problem. So let's keep on organizing with our final question. What requirements are given? Aditi wants to get donuts and a cup of orange juice, but we're told she only has $12. So the cost of the donuts plus the cost of the orange juice has to be under $12. Let's make a note of that. Aditi only has $12, and the cost of the donuts plus the cost of the orange juice has to be less than $12, or it could be exactly $12. Maybe Aditi wants to use all of her money. So do we know any symbol that represents less than a number or equal to it? Yes, we do. We have our less than or equal to sign. So the cost of the donuts plus the cost of the orange juice has to be less than or equal to $12. So already in step 1 of understanding the problem, we came up with an inequality. And this could be helpful. Now that we've answered our questions here, we should have a good understanding of the problem. So we can move on to step 2. Step 2 is to make a plan. And we have some tools here we can use to make our plan. Looking at the first question, have you seen this type of problem before? Maybe you've seen a problem dealing with the cost of different items, but let's just say this is the first time you've seen this type of problem. So we'll answer no here. Looking at the second question, is all the info in the problem useful, or is some of it unnecessary? You could argue that it doesn't really matter where Aditi is getting her donuts. We're told that it's Dunkin' Donuts, but you could replace that with any other donut shop, and it really wouldn't change what we're trying to find, which is how many donuts Aditi can get with her $12. Other than that, it looks like all the information is useful in this problem. So let's keep going. Moving on to our third question. Do you know any useful equations or formulas? Well, yes. Yes, we do. Didn't we just make one? It's not technically an equation, it's an inequality, but we want to find out how many donuts Aditi can get, and the cost of the donuts depends on how many she gets. So there could be something useful there. Okay, let's keep going down our list. Do you know a related problem or concept that can help you here? Yes, we do. We've spent some time learning about linear inequalities. That knowledge could be helpful here. And finally, our last question, can you draw a table, graph, or picture? I'm not sure. It doesn't seem like a picture would help here. We could draw some donuts and orange juice, but I don't know if that would help us. Let's just say not sure. We could always come back to that if we're struggling later on. So we've gone through this list of tools to help us make a plan. So what should we do? Well, as we mentioned before, our inequality up here might be useful. So how about we take a deeper look at that inequality and see if it can help us find the number of donuts Aditi can get. This might work, it might not, but it's somewhere to start. This method we have for solving problems is supposed to help you, but not every plan that you make is going to work. You might need to come back and make a new plan, and that's okay. So now that we have a plan, we can move on to step 3. Step 3 is carry out the plan. So we'll bring down our inequality. We have the cost of donuts plus the cost of orange juice is less than or equal to $12. Let's see if we can simplify this. We're told that Aditi is getting a cup of orange juice, and 1 cup costs $3. So we can replace this piece with $3. And what about the cost of donuts? As we mentioned before, the cost of donuts depends on how many donuts Aditi gets. And we don't know that. That's what we're trying to find. So let's think about what we know. We know that one donut is going to be 60 cents. Let's say that Aditi ends up getting 2 donuts. So 2 donuts we can think of as 2 times 60 cents. In a similar way, 3 donuts would be 3 times 60 cents. So however many donuts Aditi gets, it's going to be that number times 60 cents. So this is where it can be helpful to make a variable. Let's say that D is the number of donuts Aditi can get. D is a variable. It's a number in disguise. So if Aditi got D number of donuts, how much would it cost? If we look above, we've made a little pattern here. 2 donuts equals 2 times 60 cents. 3 donuts equals 3 times 60 cents. So following that pattern, D number of donuts is equal to D times 60 cents. Again, we don't know how many donuts Aditi can get. That's what we're trying to find. So we're just representing that with a variable. And now we can add to our inequality. If the number of donuts Aditi gets is D, then the cost would be D times 60 cents. So let's rewrite our inequality using the new information we have. We can say that D, number of donuts, times 60 cents plus $3 is less than or equal to $12. The problem looks a lot simpler now, and all we have to do is get D by itself, and we'll have our answer. We'll have the number of donuts Aditi can get. So we'll start by subtracting 3 from both sides. That leads to D times 60 cents, and 12 minus 3 is 9. You might recognize that 0.6 is the same as 3/5. So we can rewrite our problem like that, which means we can multiply both sides by the reciprocal of 3/5, which is the fraction flipped, or 5/3. Since we can multiply numbers in any order, we can cancel the 5s and the 3s. And on the right side, we can write 9 as 9/1. We can rewrite 9 as 3 times 3. And that lets us cancel out a 3. Let's clean up this mess. On the left side, we're left with just D. And on the right side, we have 5 times 3, which gives us 15. And on the bottom, it would be 1 times 1. Since dividing out that 3 left us with a 1, and we can clean it up a bit more with 15 divided by 1 is 15. So we have D is less than or equal to 15. And what is D? D is the number of donuts Aditi can get. That's what we're looking for. So we're saying the number of donuts Aditi can get is less than or equal to 15. Or we can say it's at most 15. Aditi can get at most 15 donuts. All right, we carried out our plan and we got an answer. Let's finish with step 4. Step 4 is check the solution. We ask ourselves, is your answer reasonable? So we're saying Aditi can get at most 15 donuts. The number 15 seems reasonable. It's common for people to get a dozen donuts, which is 12. If our answer was much bigger, like 150 donuts, that is unreasonable. Most people don't get 150 donuts, especially with $12. So if you got a number that big, you likely made some error in your work. And also, if you got a number that was really small, like 2/3, that is also not reasonable. If you go to a donut shop and ask for 2/3 of a donut, they will ask you to leave. So it's important to not skip this step, checking the solution. We're working with real world scenarios, so you want to make sure your answer makes sense in the real world. And again, this method we're learning to solve word problems, we're not learning it just to get an A on a test. We're learning it to help you become better at solving problems in your own life. And as you work through a challenge or complete a task or work towards a goal, you're going to want to ask yourself, does this make sense? If your plan to get to the bus on time is to wake up 2 minutes before the bus gets here and run, you should ask yourself, does that make sense? Is that reasonable? Is that a good idea? So as you work through these problems, see how you can apply them to your own life. I think you'll be surprised by how much this problem-solving method can help you.